Hi everyone. Hi everyone. Thank you for coming. Hi folks. As you can guess, I'm Pasha Finkelshteyn and I'm talking about Spring and Kotlin, yeah. And I work at Bellsoft. I have to put this logo at the beginning of my presentation, just so you know. I'm proud. Yeah. Before that, it was JetBrains. Now it's Bellsoft. Yeah, but, who am I to talk about these things anyway? You can guess yeah. You probably read it somewhere on the agenda. I'm Pasha Finkelshteyn, and I'm a developer advocate at Bellsoft. What does it mean? It means that, well, I'm trying to be a friend of developers, to listen to them, to understand what they need, and hopefully improve our products. But before that, I had like 10 years in JVM. Actually, it's already 15. I was a data engineer for some time, so I wrote code in Scala, and I didn't count it here. But I actually in JVM for almost 15 years. And I still continue writing code. You cannot stop because, well, I should know what's going on in the world of development. And yeah, the majority of this time I was very good friend of Spring. I loved it. Still love it. Not so much in JPA. My first 7 years were with JPA, and then last 8 were without JPA. You can find me by this weird nickname on Twitter, and if you are not into Twitter, then I go by Asmodee everywhere else: Mastodon, LinkedIn, GitHub, whatever. Obviously, you can find me on the bottom left part of my slide, almost on every slide, just in case if you forgot who am I. I'm Pasha Finkelshteyn, yeah, and I work at Bellsoft. Who is Bellsoft anyways? Bellsoft is a vendor of Liberica JDK. Liberica JDK, who knows anything about it? It's interesting. Do you know that Liberica JDK is officially recommended by Spring? Like, if you read the reference documentation for Spring, for example, how to build native image of your Spring application, they have direct link to our site because, well, they propose to use native image kit by Bellsoft. We also an author of JEP for Java compatibility with ARM32. We implemented it, and then we implemented Alpine support in Java. Lots of things. And yeah, what does it mean? We know our stuff, and we write a lot about Spring, about Java. Here's the QR code which leads you to our blog. Probably you want to read it, or probably you want to subscribe. I think that we do useful things. If you don't, well, I'm fine with it. Anyways, I hope that during this talk you will find at least something you don't know yet. At least one small something. Then my goal is achieved. Before we start, how many of you write code in Kotlin? Wow. So all of you, I believe, read code in Kotlin. It's amazing. It means that I don't need to explain basics. So yeah, let me jump directly to my example. I will explain everything on a nano service. There are microservices. They have some logics. My thing do not have any logic whatsoever. Like controller, service, repository. That's all. Nothing. And still there are some interesting parts. On MVC, obviously, because, well, it's the most popular thing you write in Spring validation, because it's hard to live without validation. I will showcase JPA and, well, some things about JPA and JDBC. I will try to showcase something about tests, but let's see if we have enough time. I always start from start.spring.io, just because, well, it's the easiest. Oh, wow. It's old. Sorry, don't look at this slide. You get the basic idea, right? I try to use latest version of Spring. I last tested it on 3.3, I promise. Everything works on 3.3, I just forgot to update the slide. So, Gradle Kotlin 3.1.0, 3.3. Pasha, hold yourself. So yeah, this is the set of libraries I'll be talking about. And when we hit the button generate on the start.spring.io, we have only 2 files generated in our archive, build Gradle KTS. I won't even explain it. I will dive in some parts of it. It's extremely long, 129 or something lines. Let's jump directly to the main class. And it is actually a very simple class, right? It has some synthetic class sample application, just to put Spring Boot application annotation on top of it. And also, it has this run application inside the main. Who knows this notation? What does it mean, run application and sample application inside triangle brackets? Okay. So yeah, there is such a thing in Kotlin called reified generics. If you write libraries, you probably know about it, otherwise you don't care. But this is a nice way to not pass .class arguments in the functions. It's just an extension function on the, just a static function, run application, to which you pass arguments. Internally, it does the same thing we would otherwise do in our Java, Spring application.run, our class, and pass arguments there. And well, it's the first thing you can do in your own code. When you see that, that something in Java, you use some library in Java that accepts class, you can create a new function with a reified generic. It should be an inline function with a reified generic, and use it this way, just to make API a little bit nicer. Let's start implementing our application. I always start from MVC plus validation, because, well, it's like, for me, it's a sane way to do something useful for customer. I immediately start thinking about domain from their perspective, not from mine. Obviously, it's not that important in our Nano application, Nano service. But, well, in other scenario, it actually could be very meaningful to create API first, and then all the logics behind the API. The controller in Spring looks very simple. It's your usual request mapping. Everybody knows what's request mapping, yes? Yeah, nice, cool. We have a function with post mapping on it, and it doesn't even have a body. This function doesn't have a body. It's a fun function that doesn't have a body. It has a request body and valid. Who knows what does valid annotation means? Nice. For valid annotation that means that we should check not only the top level argument that we actually got the person, but we should dig inside the person and check that person is actually valid. Person is, by the way, a very simple data class with 2 fields, constructor parameters, name and age. So in our case, valid does mean that name should be string and age should be int. And both of them shouldn't be null. Wow, it's weird. Give me a second. What? It's fast. Okay. Sorry, my code is also buggy sometimes. I don't know how did I mention it. Didn't I notice it? So let's test it. Let's test our post on our person, and I just use an idea built-in HTTP client to create a post request with an empty body of type application JSON. So I kind of want to check if Spring validates person for me. And the answer is 400 byte request with timestamp and so on. And well, since person is non-nullable, it is validated without not null annotation. But how? The thing is, there are several lines in our Kotlin Gradle KTS, build Gradle KTS, which I didn't show you. They say something like this. For each task with Kotlin compile, we should add compiler argument called xjsr 305 equals strict. What does it mean? What is JSR 305? JSR 305 is an annotation for software defect detection. For us, what's important that it checks non-null and check for null annotations. And Kotlin, when compiles your code with this argument, adds an annotation non-null to each non-nullable argument. Come on. Sorry for that. Also, there are all kinds of different annotations, localization, and so on. Again. OK. Now let's test. Let's pass the real person, like a real object, with name null and age null. And we still get our 400 bad request, which is a good thing. And on server, we can see this error, which says us that there is something, name is missing. This is important part. And also, now let's try to pass a person with a name, and it should fail, I think, because now name age is also non-nullable. And we somehow get 200, which is kind of okay. So it will try to save or whatever, do whatever without the person, but it shouldn't work, right? It was my face when I saw it first time. Yeah, okay. Something like that. Let's look at our person again. So name is string, age is double. They're both not nullable. It should not work. Why does it work? The thing is, in JVM, primitive types have default values, right? So what are primitive types? Do I have the list here? Yeah, they're double, int, float, char, short, byte, and boolean. They have default values. Double have 0, all of them have 0, boolean has false by default. And Kotlin kind of struggles with it, because, I mean, you should either put question mark on your type and make it nullable and make an object wrapper. You probably don't want to do it. Yeah, you can do something like this. Put an annotation non-null on the double field and make double nullable. Of course, it will save the problem. And let's check it. We pass age null. Now, OK. Bad request, and obviously there will be some error on our server. Field error in object person on field age rejected value null. Now, it's how it should work. It's not very beautiful. You should be careful about it, though. For controllers and for Jackson, it's solvable. Jackson has this nice setting, which is called Jackson deserialization fail on null for primitives, which solves this problem for you. Like, you will avoid putting this non-nulls and question marks on your fields. But imagine that you do not work with Jackson. You have integration with gRPC or whatever, your own custom protocol. You should be mindful about this semi-feature that JVM has default values for primitive types. And you should have a way to work it around. Either putting some additional validation on it, like I did in my example with controller, with the data class, non-null and question mark, or doing something like Spring did in their configuration, like check for nulls in primitives. For whom it's a new information. Yay! I promised. You learned something new. That's cool. I mean, half of the audience is semi-satisfied. Let's make a quick summary. So, please use XJSR 305 strict if you use Gradle, and if you do not use starter Spring IO, if you do not generate your starter projects at start Spring IO, it makes sense to put it there just to have additional validations. For JVM primitive types, you have to pull field not null or solve it some other way, like Jackson does. Yeah, sometimes you can work it around with Jackson. Now let's dive into JPA a bit. Who uses JPA? 3/4 of the audience. I'm sorry, folks. Who likes JPA? almost the same people, almost the same people. So Kotlin has this concept of data classes. You are probably all familiar with it. Let's look at our nan entity. It has an entity annotation in it, like it's a data class. It has values name and age. And yeah, here are some issues of this class. It is a data class. And yeah. And there is no arg constructor, because you cannot have no arg constructor in data class. It is kind of obvious, right? Because data class is a class that is supposed to have data by default. So if it doesn't have any fields, why is it a data class? It is something different. You could do it with Podjo. You cannot do it with data class. So data classes have, by default, copy function equals hashcode and component x functions defined. Did I put copy twice here? My bad. It's a very important function, very important and very useful, but not in the context of entities. So we actually don't need them, any of them. We don't need default implementation of equals. We don't need default implementation of hashcode. We don't need this component something functions. Yeah. So let's get rid of this data keyword. Something like this. Now, there is an issue. Name and age are values. And JPA doesn't work this way. For JPA to work correctly with your entities, everything should be mutable. I don't like it, but life is life, right? It was the age, I mean, before I even started programming. I started programming like 15 years ago. Java beans were already there. They appeared in Java 1.1, long before I started. So yeah, it seems we have to convert vals to vars. Now, we have these annotations. ID, generated value, column, and it's a class. And all these annotations are on the arguments of the constructor. Who thinks that JPA will work this way? Nobody. Because I gave it out with my question, right? Well, it was stupid for me. But how do we fix it anyways? Of course, there is a way we can put like field, column, column, and so on, but it's not beautiful. There is actually a magic plugin, and it's also in our generated build Gradle KTS, which is called plugin JPA, and it obviously shouldn't be 1.8.0. It should be 2.0 because JetBrains just released the second version of Kotlin. It does some useful transformation to your code, not to your code, to generated classes actually. First of all, it puts annotations on the fields without you explicitly specifying it. Explicitly specifying that please put this annotation on field, it makes code clunky. I usually don't want it to be this way. I want magic to happen automatically. It's Kotlin. It should be beautiful. Well, at least as beautiful as possible. And also, it adds a default constructor and bytecode. In Kotlin, the default constructor without arguments would be impossible for data classes, obviously, because again, they are intended to have some data inside. Doesn't make sense to add a constructor that does nothing. So in bytecode, there appears an invisible constructor that does nothing. So if you will try to construct this entity from Java, it will have all the fields set to null, even though fields are defined as not nullable. So our current result is something like this. But is it enough? I think that not quite. At the very least, we should redefine equals and hashcode. Who knows how to define hashcode and equals correctly for JPA entities? 1, 2, 3, 4, 5, 6, 7 hands. Yeah, I don't know either. It's actually a difficult, complex question. ByteBuddy wrote an amazing article how to do it in different situations. This is one of ideas you can use. You can always compare by ID or always return 0 as a hash code. At least this way, your sets containing your entities will work more or less correctly. So if this entity is not attached to the database, then it will then JPA will think that they all are different because they don't have IDs. Otherwise, it will compare entities by ID. But it's only one approach. There are different approaches. And yeah, it will be a homework. I won't dive deeper into it. Please. Then, JDBC. This part I like more. I like more control over my code. Again, it's up to you to decide. Let's imagine that we have a very simple query like this. Select the asterisk from users, well, where ID equals question mark. And I will show you code snippets with this particular query, but do not think that I'm that basic. This is queries I usually have in my applications. Yeah, and then something like this. Because, well, it's just a simple query with from my pet project. It's a small library, and I want to query some data about my books. But if I would put it into my code snippets down the line, it wouldn't be readable, so yeah, we'll stick to the simple one, right? Just imagine that instead of select asterisk here, you see this fat query. So let's look at our usual flow when we work with JDBC template. We have some function called which returns list of people, find by ID. We have this JDBC template query. Then we have our query itself. Then we pass a euro mapper in there, and then we pass ID. What is our mapper? It's class like this. Also can be lambda. We'll look at it a little bit later. It has only one function, maprow, that takes ID from result set, string and double, and creates a new person. Kinda basic, right? We can try to inline this stuff. Because I didn't like the previous thing, because here we have ID after our mapper. But if we inline it, it becomes even worse somehow. But at least we have our mapper inside our code, because otherwise we will have lots of mappers all over our repository. And it will be really hard to navigate over them. Yeah, also, yeah, well, I think you can read it, right? Result set, then we extract everything from database and create a new person. I don't know why it's ID1. Sorry, it's a simple typo. And yeah, and the last thing we pass to our function is user ID. And again, just imagine it's not select asterisk from users, it's those fat query. So fat query is in one place, and arguments of this fat query is in completely different place, like 10, 12, 13 lines later. And yeah, so we have to choose. Either we have too many mappers, or parameters are too far away from the query. I don't like neither of them. So why should it be so? Let's look at the signature of this function in Java. It's a query, then it accepts SQL, our line, our string, then row mapper, and then variable arguments of nullable objects. Because in Java you cannot put variable arguments as the middle argument or as the first argument. Java just won't understand what's going on. Here is how the same thing works in Kotlin. JDBC template.query, then our query, then first argument, which is user ID in our case, and only then we have our mapper. Mapper does something obvious, the very same, By the way, did you notice that in this line we use underscore because we actually don't care about the row number we work with, instead of trying to give it a meaningful name that we want later use? Yeah, and then the code is almost Java style. Well, we use val, and so instead of string double whatever, but otherwise it's the same. The thing is, in Kotlin, vararg doesn't have to be in the last position, and we can use unused parameters as underscore. How does it work? With the help of extension functions. Inside Spring, it's just Kotlin extension for Spring. We have this function, extension function query on JDBC operations, which first accepts SQL, then it accepts our arguments, and then it accepts the actual mapper. And it works. I don't know why can it be this way in Java, but anyways. And the last argument in the first part of the code is mapper. When it's lambda, we can use it like here. Oh, sorry. Like here. We can just extract the curly braces out of usual parents. You can do the same for your own code. So imagine you have like function called transform strings, and you can, in Java, you have to pass some mapper. How should we transform strings? And then you pass the arguments, strings. In Kotlin, it will be better. In Kotlin, it will be more logical. You can pass multiple strings you want to transform, and then lambda with which you can transform the thing. So it's not Spring only. You can actually use it on top of your own libraries, on top of third-party libraries, because there are no any limitations on what you can put your extension function. There are many Kotlin extensions for Spring Bean, Spring Consist, and so for many of them. We won't dive in all of them because it will take, I don't know, 3 hours more. But some of them are very interesting, and we will dive in some of them. In particular, I want to dive a little bit into reactive persistence. Who is familiar with reactive persistence with Spring? Okay. Who read about it? It's not the same as used it. Okay. So there is a concept called, by the way, the image on the right is the best thing Midjourney could come up for me to illustrate reactive programming. I kind of agree. So what is reactive? Reactive is non-blocking things. So we do some call, and then our thread is not waiting for response. It might be reused for something else. It's asynchronous, so we operate on things like futures that will eventually give us results. In JavaScript, it will be called promise, something like that. And it handles back pressure. It's a very important thing. So it's like if we can process only one item per second, backend shouldn't send us more than one item per second. It's very cool and very important. It means that our clients are never overloaded. The all load is on the server. It should keep a lot of data inside it. The result is a monad. Just kidding, sorry. The result is either mono. Mono produces 1 to 0, 0 to 1 elements, like exactly one person, or exactly 0 person if nothing matches our query. And flow, which can produce from 0 to infinity items. For example, if you will try to select asterisk from your database, it will produce infinity. Okay, very limited, very small infinity probably in some cases. Anyways, it's generic functions. They are like generic classes which behave a little bit like collections, but they return your result later. Kotlin works a little bit different. Kotlin operates with an entity called coroutine. And on suspend functions. Suspend functions can be called from coroutine context or from another suspend functions. Who uses suspend functions in their code? 1/3 of the audience. I can agree. Sometimes it's hard, but sometimes it's interesting. Contrary to reactive programming with reactor in Spring, usually suspend functions return very simple types like lists, strings, and so on. Let's look at the example. We have suspend function, random number, that returns integer. What it does, it calls one service to obtain first random number. It calls second service to obtain second random number. And then it sums this random numbers. What is nice, internally, JVM can stop execution after each of these statements, like after this or after this, and give because we don't know how these services obtain their random numbers. Maybe it takes a long time, but for us, we can utilize threads better. This thread, which otherwise would just wait for the result, will give its resources to another thread to do something else useful. And yeah, when you work with some libraries, you end up with suspend functions everywhere. Yeah, I know I'm not the buzz light here. He's much more beautiful, but we have what we have, right? So let's look at Spring R2DBC. Usually everything starts with a very simple repository. Like we can create it ourselves. We should pass connection factory inside it. And then we create a client, like database client.create connection factory. At this point, we are ready to create R2DBC requests. Just in case, to work with R2DBC, we have to add one more dependency. For example, Postgres R2DBC, SQLite R2DBC, whatever. Several databases are supported. Let's write some real code, some function, for example. It will be a suspend function. We don't want to deal with this flux and mono in our Kotlin, and Spring has extension functions to help us find them. So, for example, create user and return ID. We use client, then we call our query. You can see that I have variable called email, argument called email, which I can later bind. It will be incorrect email, I can promise you. Well, I can't. Eventually it will be a correct email, but most probably it won't be. Then we call fetch, and it's a part of Spring. And then we call this await single function, which actually isn't part of the core R2DBC implementation. It's a part of R2DBC extension functions. Which looks like this. It fetches the first entity, which returns mono, and then it calls await single or none, and it wraps everything in a suspend function. So we don't think about these monos, fluxes, and so on. And eventually, our function returns, well, our ID from the map, which has been returned by Spring R2DBC data. Let's speak about transactions a bit. Transactions are a tricky topic. They were not implemented for some time, but they are already implemented in this reactive world. And for us, it actually looks exactly like it would look without any reactive stuff. We have this transaction. Come on. We have this transactional annotation. Sorry, it's unfeasible. We can create, create a user, get its ID, and we can try to create a new user with the same ID. It will throw an exception, and because function is transactional, the first user won't be saved, which is usually the result we want to have. If we don't want to have this result, we just remove the transactional annotations and everything is good. Look at this. From the client, from the consumer standpoint, nothing changes. You could as well use Spring Data JDBC. The semantics would be exactly the same. The only thing that actually changes for you is it's now suspend function. And this is a good thing because your controllers are suspend, because you don't want your clients to actually use the whole thread to wait for the response. Your services are suspend, and your repositories are suspend. Everything is reactive, everything is synchronous in this pipeline. And well, you just don't think about it. Let's talk about repositories. You probably know Spring Data JPA repositories. I won't talk about them. There are coroutine repositories too, and they are used in the same very way. For example, this example from the documentation. Interface user, but I have this example in my code too. It implements a coroutine CRUD repository from user and long. If we will look at coroutine CRUD repository, it looks like other Spring repositories, but signature of functions is slightly different. First of all, it has, for example, save, and this is a suspend function, which is cool. It means that we shouldn't actively wait until our entity will be saved. When it will be saved, it will return the ID of the saved entity. Or, for example, find all. This is something new. We see flow here. Flow is like Flux in Reactive. It's a sync unbounded collection. And since it's implemented on top of Reactor project, it also handles back pressure and all this kinds of stuff for you. Now let's add some functions to our repository. For example, find one. It will just return a user, but it's a suspend function. We don't have to write any magic for it to work. It will just work. Or find by first name. There can be multiple users with the same first name, obviously. And it will return a flow of users. And we can call it only from coroutine context, because, well, flow is also a synchronous thing. Or, for example, find all by first name. This will work too, because, well, if we believe in ourselves, everything is possible. For example, returning list instead of flow, because probably you don't want to deal with all this asynchronous stuff at all, and you are fine with collecting everything in your memory. I am this kind of human. Yeah. Function is either suspend or it returns flow, obviously. And transactions work exactly the same way. For example, we instantiate this user, then we save it to our repository, then we create a copy of this user. We are not bound by any JPA limitations. We can actually user can be actually a data class. It's perfectly fine. This line will throw an exception and everything will be rolled back. Nothing will be saved. Now, configuration. It is actually my favorite part because nobody knows it. But I will ask, just in case, who uses Kotlin bin definition configuration DSL? Nice. Nobody knows it. Or nobody uses it, I don't care. So in Java, we should have this configuration classes. In Java with Spring, we should have these configuration classes. We should define beans in them. Each bean is a function that is notated with notation bean. I don't like it. Here is how we do this stuff in Kotlin. We have this value beans, and we can just write bean, and we can write lambda that will produce our bean. That's all. I mean, in Java, it'd be 4 lines of code. Bean, then we should return something. And in Kotlin, without bean configuration, DSL2, obviously. And there's the very function signature. So 4 lines instead of 1. Or let's say we need a custom bean. For example, this JSON logger. It accepts object mapper as its argument, and it does some stupid logics. I just wanted to write something in here. And for it to work inside our bean configuration DSL, we can write it this way, like bean JSON logger. We put here a reference to a constructor of our JSON logger, and it just works. Even though JSON logger actually requires an argument of type of object mapper, Spring will find this object mapper inside context and provide it to the constructor, which is, to me, very nice. Or we can use any arbitrary logic here. For example, this again, very stupid example, but it will be virtually impossible to write in Java with this annotation bean. We have all these smart, conditional missing bin, and so on. But here I write an actual code whereas my bin should be lazy or not. I mean, can you do it in Java? I'm not sure. I'm not even sure if you can do it in XML. You can do it in Groovy, but I think nobody here uses Groovy. Don't tell me. I don't know. So yeah, if random next Boolean, then our bin will be Norway, else, well, whatever. Okay, how do we use these bins initialized this way? Because when we use Java bin configuration DSL, or Java bin configuration, it's been injected automatically, right? We should return to our main function here, run application with sample application something, and we also have our bins defined. Let's change it this way. Actually, run application accepts Lambda, with which we can customize something inside Spring context. For example, we can add initializers our bins. Yeah, like this. And we will run our application, and we will see our usual started Spring application in 1.7 seconds, which is very nice. It kind of means it works. Woo! But let's test it. We'll create a random component for the sake of test. I'll call it myBin, and it accepts our JSON logger we created earlier. And it has very dumb test again, because I just wanted to write some code. I like writing code. And now we write our usual test, Spring Boot test. We afterwire our bin. Then we create test. Assert equals something. Launching what? No qualifying bin of type JSON logger, but why? We have initialized our application. We explicitly said add initializers. I mean, what's going on? That is because our tests do not actually know anything about our main function, right? They do not call main function. They initialize Spring context in their own sophisticated way, which is almost the same as our main function, but who cares? So to actually make this bin configuration work, we need to do a little something. I don't like that we should do it, but what are you going to do? It's Spring. There are workarounds for everything. We should create a class extending application context class initializer of generic application context. Welcome to the Java world. Well, in C++ it would be worse probably. And we have to override one function initialize that again accepts generic application context, and then we call bins.initialize context. It's not that much of a code, and you pretty much can just copy paste it into your application if you use Kotlin bin definition DSL. And after that, you put application YAML into application YAML with small line context.initializer.classes. Here, you cannot just copy paste it. You should replace my package with your package and put bins initializer there. But shouldn't be that complex, I believe. And after that, we remove this lambda and we launch our application as it was launched before. With just run application, sample application args. And it just works. After that, it just works. I mean, no downsides here. Much less code, arbitrary logic in your bin definition. Beautiful. Now to the most painful and the last, I think, topic of our talk today, Spring Security. Who works with Spring Security? Who likes to work with Spring Security? I feel you. Like, I mean, well, we don't have anything else, right? They force us. But even Spring Security is better. Even Spring Security is better with Kotlin bin definition DSL. Look at this. It's the same bins we defined earlier, but now we want to add a security bin. Here is how it looks. Here is how it starts. We add value HTTP, which equals ref to HTTP security. I know it's hard to understand this line. Took me some digging, so I will save it to you. What it does, it finds at initialization time, it finds the bin of type HTTP security in context. If it's not initialized yet, it initializes it with all its dependencies and so on. And after that, HTTP, the very HTTP we just created on line 8, on line 9, we can use it as a receiver of our Lambda. So it has a function invoke defined on it, and which accepts one Lambda, so we can write it like this, HTTP. And then we set up our HTTP all the way we want. We put CSRF disable, do not do it in production. I mean, seriously. HTTP basic, security matchers, all this dark magic of Spring Security, authorized requests, and so on. And after that, we say HTTP build. And let me say, to me, it's just significantly more beautiful than what we have in Java and in regular DSL, where we put tra-la-la-la and tra-la-la-la and then something complex is going on, like with this authorized requests, and then and. It's barely readable. And when you run after formatter on it, which I do all the time, it makes it even less readable. In Kotlin, after format, we won't make anything worse. And I love it. So what did I learn? And probably you learned something with me today. First of all, always generate the project with start Spring IO. Well, it's a joke. If you have your own template, that's fine. But refi generics might make an API better. It's the thing you can use in your own code when you use any third-party libraries. Validation is better with Kotlin. You shouldn't put not null on every argument you use. I wanted to put a word there, but I will skip it. Data classes should not be used with JPA. That's a bad idea. It won't make any good, really, even though data classes are nice by themselves. JDBC is also simpler with Kotlin because it's just more readable, especially for big queries, because you can put mappers at the end of your function call, not at the beginning. R2DBC becomes simpler with coroutines because you don't have to mess with all these flags and monods. You just use suspend functions and that's all. It becomes more or less transparent. Bin definition DSL is really awesome. I mean, just so much readable, so much more efficient. I didn't compare timing, like how it affects your startup. I don't know. It shouldn't be that important, but if it's critical for you, please benchmark. But with security, it makes even more sense, because with security, we can see how nicely we can embed one DSL into another DSL, which is how it should be in Kotlin. DSL is actually a Kotlin thing. At this point, I want to say thank you, and now it's your time again. If you now believe that Bellsoft does something interesting, you can subscribe to our news. Otherwise, it's time for your questions. Thank you. Questions? Questions? I can count to 10, but yeah, there is a question.
Hi.
Hey.
Talking about GPA and data classes,
Yeah.
I came across with some resistance from Java guys against Kotlin because of this issue. And what do you think about using a mix of Kotlin and Lombok in this specific situation? Because as for me, I'm not thinking that it is a good idea, but
I don't like it either. I think that, well, first of all, I don't like Lombok, even though it saves some code. To me, it's a constant issue in my IntelliJ IDEA, because when I navigate to code, IDEA constantly complains that source code doesn't match the class file. For whatever reason, we know what is the reason. In generated class file, there are getters, setters, and so on. Also, you still have to override equals hash code. I mean, the win from the Lombok here will be negligible, in my opinion. So I would just use Java classes. But question is, how Java classes are better than Kotlin classes? I mean, You can just write class my entity, put an annotation entity on it, put all the same arguments, redefine equals and hash code, which you will do anyways. And you shouldn't write any getters and setters, and you shouldn't use Lombok. So I mean, if it's the only argument versus Kotlin, something is wrong here. I believe there are some wrong parts in Kotlin, but it's definitely not not one of them. You just don't use data classes with JPA, that's all. You can use them in all other places if you want. If you use mapstruct, there are ways to make mapstruct work with Kotlin. Or you can write your own mappers or whatever. There are solutions to everything. It shouldn't be argument against Kotlin, really. Did I answer the question?
Yeah.
Thank you.
First of all, thank you for the presentation. I actually have an interesting question regarding the Kotlin. Will be still relevant in the backend development? Because what I see the tendency from every new JDK, so the JDK basically copies the homework from the Kotlin.
Yep.
In terms of some functionalities like object destruction or maybe, I don't know, infer types.
Yep.
And will it still be relevant in 2 or 3 years?
Yes.
Because
there are some cards in the sleeve. And well, Kotlin had to slow down a bit before the release of 2.0 to make sure that everything is backwards compatible, that no client or no user struggles with the new version of Kotlin. But for example, there is one thing that is relatively understandable how to implement in Kotlin, and nobody knows, and nobody wishes to understand it in Java, is union types. Like, what if I wanna get an argument of type string or integer here? We don't know how to do it in Java. Or maybe implicit interfaces. Well, nobody's speaking about implicit. I should be transparent. Nobody in JetBrains speaks about implicit interfaces now. But union types are a real topic. Yes. They will be there one day. Maybe in 2.2, for example. Not today. But they will be there. And Java is still not there. And even speaking about virtual threads, for example, it's a very interesting feature, very interesting. But do we really use it? Do we really use this threading model? With coroutines, it's kind of transparent. I know coroutines have their overhead. Roman Elizarov gave a very nice talk about it. I don't remember the name, but his idea was eventually JetBrains will implement a coroutine dispatcher on top of virtual threads. And this way, Kotlin will still win from Java. And Java cannot really win. It can try to steal some ideas. Pattern matching in Java is very nice. It will be there one day in Kotlin. But there are things like union types, which are almost impossible to implement in Java, and then even not discussing it.
Thank you.
Thank you for the question. More questions? Okay, the lunch is waiting. Thank you very much.